Good morning, children, and welcome to the new normal. As I said yesterday in our chat, I believe that's what's going to happen. We're going to plow ahead with the content. AP doesn't quite know what's going on. As soon as I find out, I will share with you. I'm sure the College Board will also. But in the meantime, we're going to plow ahead with our other optical processes. So we finished up with double slit diffraction, talked very briefly about single slit diffraction, and today we're going to take a look at something called thin film interference. Now, I will warn you, this is pretty complex when you first learn it. So if you're a little confused early on, that's fine. Once you figure out how to do the problems, they're all kind of the same, and they're actually pretty simple, but they rely upon you understanding that whole interference by constructive and destructive interference by phase shifting different ways. So the discussion we had with where the images showed up in double slit diffraction is similar. So you've all probably had the experience of looking at a parking lot, seeing a drop of oil on water, and you get this really cool rainbow effect. So there's a good picture over here, the same thing here. And of course, if you ever blown bubbles, the exact same thing happens. These are thin films. So here we have a thin film of oil on top of water. Here we have a thin film of air, water, soap mixture, and then air. So these are very thin layers of material that interact with light and cause some cool stuff to happen. I'm going to walk you slowly through this. I'll try to break this in little 5-minute videos, so not to torment you. So as we talked about before, Richard Feynman was one of these cool guys who really wanted to look at what light really was doing. And one of the things we talked about previously was this idea about reflection and refraction are not mutually exclusive. So previously we said, hey, light, when it hits a boundary, either will reflect off that boundary or it will refract through that boundary. Well, it turns out usually both things happen. I gave the example in classes, if you stand in front of your car window, if you're standing outside your car on a sunny day, you look at the driver's side window of the car, you can see your reflection in the glass of the window, but you can also see through the glass. You can actually see inside your car. So light is reflecting off the surface and passing through. So here we have a picture of a thin film, and this thin film has to be a piece of glass, so it's our regular process we talked about before. Light comes down through the air, strikes a boundary, some of that light refracts through, some of that light reflects. The light that passes through will continue and then again hit another boundary, and some of that light will refract and some of that light will reflect. And you'll notice that we have regular refraction. We're going from a low density to a high density, bends towards the normal. From a high density to a low density, bends away from the normal, and these two beams will be parallel to each other. Likewise, we'll get refraction at the boundary. So I made the thickness of the line representative of the intensity of the brightness. So half the light goes through, half reflects, half the light goes through, and half reflects. Those numbers are arbitrary. And then finally, of course, we'll have, the key thing is this, the light that hits the surface reflects, and the light that goes down through and reflects off this lower boundary also comes out, and it's these two light rays that we're interested in. These two light rays are going to interfere either constructively or destructively to create some color pattern. So if we go back to this picture, why do I get yellow here and purple here and blue here and a little bit of green? There's not a lot of green in there. Why is that? Why do we get certain colors show up and others don't show up? Or they show up in certain locations. So that's what thin films look at. So again, if you look at this, so the soap bubble is a thin layer of air to soap water to air. And we're going to look at that boundary, and again, you'll notice that some colors show up and some colors don't show up. This is a lab that we typically do. Unfortunately, you're not going to be able to do this unless you go into your kitchen, grab a Dixie cup, poke a hole through the paper cup, dip it in the soap solution, and then blow bubbles, and you'll see these patterns. So we usually spend a whole period doing this in the back of the room. It's lots of fun. You don't get to do it this year, unfortunately. Later on, if you actually post a picture of you doing this, I'll give you bonus credit. So Jess, I guarantee you're going to be making your soap solution. So go ahead and do that. Just don't share the cups. I don't want anybody getting any horrible disease. Anyway, so again, you can see this pretty easily in a regular bubble if you have a bubble solution. Now, I'm going to start the next video in a second to show you how this process goes. So in an attempt to keep it 5 minutes or less, that's my first 5-minute video.